All right, Matthew, here we go. We got lesson 2.2.2, similarity. Okay, so we just got done doing dilations. We saw that dilations do not produce shapes that are rigid motions because they make shapes that are instead what we call similar to each other. Similar shapes have congruent angles, so the angles are the same, but the sides are proportional instead, meaning that they have the same scale factor. Okay, so we did scale factor last time. So proportional sides just means the sides have the same scale factor. So on this one, it says, which side of A prime, B prime, C prime corresponds to CB? So here's CB. Which one of this big triangle corresponds to it? And it's pretty obvious. It would be B prime, C prime. So side B prime, C prime would correspond to that one. What are the relationships of the corresponding sides? Well, these two corresponding sides are parallel to each other. So first relationship, they're parallel. Any other relationships? Well, let's see. BC is 1, 2, 3, 4 units long. And B prime, C prime is 1, 2, 3, 4, 5, 6, 7, 8 units long. Aha, so B prime, C prime is double the length. That's what we called a scale factor in our last lesson in dilations. So we can see here that it's twice the size. So the image is twice the size. Or we could say the scale factor is 2. Now it says that AB, this section here, is on A prime, B prime. AC, this one here, is on A prime, C prime. But BC is not on top of B prime, C prime. Why is that? Well, this is a dilation. In a dilation, we were dilating from this point here, and so everything spreads out from that point. AB is on A prime, B prime because it was dilated from A, and AB has A in it. AC has A in it. That's why it's still on A prime, B prime, because we dilate out from that point. However, BC doesn't have A in it, so it doesn't stay on B prime, C prime. So B and C were not part of the point of dilation. Can we determine the side lengths of A prime, B prime, C prime by adding the same number each time? We said here we went from 4 to 8. So should we always add 4 is what this is asking. Well, I don't know. Let's see. This one is 3. If I add 4 to it, I get 7. But this one is 6. So adding the same amount isn't going to work. And we should have seen last time on our last lesson with dilations that we multiply when we do a dilation. And so similarity uses multiplication. It doesn't use addition. Monica dilated triangle ABC to get a different triangle. She knows that A prime, B prime is 20 units long. How long would B prime, C prime be? Okay. So we kind of need to know what the original shape was. So this side is 3, this side is 4. I don't know what this is because it's a diagonal, but since it's a right triangle, I can use the Pythagorean theorem. So to find out what AB is, we would do 3 squared plus 4 squared equals C squared. And we get 9 plus 16 equals C squared. That's 25. And then if I take the square root of both sides, I find out that C is 5. It's a 3, 4, 5 Pythagorean triple. So hopefully you notice this pattern. It's something that you should have covered last year with your triples. So 3, 4, and 5 is a pattern of the Pythagorean theorem. So here we go. We know that AB, the original, is 5. Now it says that Monica dilates it to make A prime prime B prime prime to get 20. And in part D, we said we're not adding, we are multiplying. So I can see here that to get from one point to the other one, she's multiplying by 4. So now she can find B prime prime C prime prime, because BC, we said over here, is 4 units long. If we want to go to A prime prime B prime prime, not A prime prime, B prime prime C prime prime. Okay, so this is the second time that I've done this lesson, like tried to make a video of it. And the first time I was still not quite awake with not enough coffee, so I had to stop like halfway through. Hopefully I'll make it all the way through this one. Anyways, we see here that we were multiplying by 4 to get 20. So we should multiply by 4 here and find out that B prime prime C prime prime is 16. Because it has the same scale factor. It's a scale factor of 4. That's what it means when we say that we have proportional sides. Is that if we're growing by the same amount, or the multiple of the same amount, all the sides will grow by that same amount. So this side AC, if we multiplied it by 3, we'd get 12. So the triangle would be 12, 16, 20 for A prime prime, B prime prime, C prime prime. That's what proportional means. We have the same multiplier between the original and the copy. All right. Casey's favorite letter is a C. Good for her. She decides to enlarge the C by a scale factor of, it's actually a scale factor of 3. She decides to enlarge it by a scale factor of 3. Write the ratios, so ratios means fractions, of the corresponding sides. So the biggest corresponds to the biggest. So 8 is bigger than 6, so it should correspond to 24 because 24 is bigger than 18. So the ratios, the fractions, when we do a ratio, we're always going to put the copy over the original. So it's a scale factor of 3, so this ratio should give us 3. And so the copy is 24, the original is 8. That reduces to 3. Over here, on the width part of it, the copy is 18, the original 6, which reduces to 3. That's the scale factor. This is what it means for them to be proportional, that the fractions of the corresponding sides always equal the same amount. Therefore, what we can do on these problems is we can say this fraction of 24 over 8 is going to be equal to this fraction of 18 over 6. And that's going to happen anytime we match up the corresponding sides. They're always going to be equal fractions. 3 equals 3, 24 over 8 equals 18 over 6. All right, now we're going to use that. Next one. Casey decides to make another enlargement. But we don't know what the scale factor is this time. Last time it was 3. We don't know what the scale factor is. Well, we did say that we know that 8 and x correspond to each other. So x is from the copy, 8's from the original. Then over here, we've got 72 is from the copy, and 6 is from the original. I can write this because up here, remember, we said that if it's a enlargement or a dilation or whatever you want to call it, that our sides are going to be proportional, meaning that their ratios are equal to each other. So here I have the ratios and they're equal to each other. So now we can do cross products. Now before you do cross products, you might want to reduce because this one reduces to 12 over 1. So if I do cross products at this point, I would get x times 1 is x, 8 times 12 is 96. So I know that this side must be 96 because these two are proportional to each other. All right, next one. What if Casey wants to shrink C so that the height is 2? So we're going to assume that the height is this part over here of 2. So we want to shrink C so that we get a height of 2. Okay, so if that would be true, the copy would be 2, the original would be 8. What would be the width? So we don't know what the width is, but the original has a width of 6. So these should have the same ratios being equal to each other, because that's what proportional means. Since it's a dilation or a similar shape, then the proportions should be equal to each other. Now you can start by reducing if you want, because this reduces to 1 over 4. And now you can use cross products. X times 4 is 4x, and 1 times 6 is 6. Divide by 4, you get x equals 6 over 4, which reduces to 3 over 2, or 1.5. So that would be that would be the width. So what we saw here is we have it reduces to 1/4. So everything in those triangles should reduce to 1/4. All right, what would the scale factor of 1 mean? Well, we knew a scale factor of 2 means it's doubling in size, and a scale factor of 1/2 means it's cutting in half. So a scale factor of 1 means it's the same. Nothing's changing. The scale factor of 1 means that if I'm starting off at 8, my next shape will also be 8. If I'm starting off at 6, my next shape will also be 6. So it means that the two shapes are congruent. So scale factor of 1 doesn't mean that they're different. It means they're the exact same shape. Backside. Almost done here. Okay, Rochelle drew triangle ABC and then dilated it through point A to create A prime, C prime, B prime, C prime. Okay, so here's her original, and she dilated it. So it looks like she shrunk it. So this should have a scale factor of that's a fraction, because it's getting smaller. How do we know that these triangles are similar? Because it's a dilation. Dilations create similar shapes. Redraw the triangles separately and solve for x. Okay, so if I redraw those triangles, let's try to do it really. Oh, that was bad. Oh well. Okay, so here's ABC. So A, B, C. So I can see here that A to B, that's 4 plus 6, so that's 10. A to C is x plus 9. All right, and then over here, the smaller triangle, which is A and then B prime, C prime. AB is 4, and AC prime is x. So now we want to do a proportion to solve for x. So for this one, copy over original. So it goes 4 over 10 should be equal to, since they're proportional, of x over x plus 9. I would reduce the 4 and the 10 just because it makes the numbers smaller when I do the rest of my work. Okay, now we use cross products. 5 times x is 5x. All right, be careful here. This is 2 times x plus 9, which means I have to distribute it. So I have to do 2 times x and 2 times 9. So this would be 2x plus 18. I would subtract 2x from both sides and get 3x equals 18. Divide by 3, and I would get x is equal to 6. All right, last one. Albert decided to draw an angle and then dilating it by enlarging it with a scale factor of 2. He believes that the angle that was dilated should be 120 since he doubled his size. Do you agree? Explain or not? So he thinks that this should be 120 because he doubled the size. Is he right? Of course not. What a fool. Albert is not right. He did not double it. He doubled the sides, but he did not double the angles. When you do a dilation, the angles are congruent. So no, the angles are congruent. It's the sides that become proportional to each other. So this side would be proportional to that side. All right, that's all I have for you today. Math hard. See you later. Bye-bye.